Let's step back, 2 billion years back into Earth's evolution, a time full of life. But also mass extinction. An invisible killer was on the loose, ready to change the course of history. This was a time on Earth that had a direct impact on what the world is like today, the animals that inhabit it, the food that we eat, the air that we breathe. Time to go back. Welcome to Earth 2 billion years ago. You're landing at a time when Earth is about halfway to its current age. Now, as you make your descent toward this prehistoric Earth, you'll see blobs of land and maybe some chunks of ice, separated by water. These land masses look nothing like our continents today, but that's going to change soon. As your time machine touches down, it's a bleak and rocky landscape. There are no plants, no trees, no vegetation at all, no signs of any animals either. This was a time before complex multicellular life. The only living things on Earth were microorganisms. Yeah, might be a little dull, but at least there are no predators you need to worry about. I hope. Before you step out on the ground, you'd better put on your suit that's fitted with an oxygen tank. Because while there is oxygen in the air, there isn't enough for you to breathe comfortably. It's less than 10% of today's oxygen levels. When Earth was first formed, there was only carbon dioxide, methane, and water vapor in the air. More on that in a minute. As you step out, you look into the water surrounding you. It's completely still, and there are no fish swimming in it. But it's filled with a ton of green, slimy stuff. What you're looking at is a whole lot of cyanobacteria, one of the most important bacteria to ever live on Earth. Cyanobacteria are responsible for the air we breathe, but they were also responsible for the most massive extinction event of all time. To see how this extinction event happened, we need to skip back in time even further. Another 500 million years. This time, when you land, you'll definitely need your oxygen mask because there's zero oxygen in the air. The Earth will look a lot different from what you're used to, but there will be some familiar building blocks that are still on our planet today. And it's wild to think that some things that have played a critical role in our history and will be so important for our future have been a part of our planet for billions of years. Take uranium, for example. Uranium is a naturally occurring element formed during the early stages of the universe, and it's been a part of our planet since the beginning. According to our resident experts at Uranium Royalty Corporation, just one pellet of refined uranium, about the size of your fingernail, packs about as much energy as 149 gallons of oil. That's some serious power. This kind of energy is more important than ever in today's world. We're facing an energy demand surge, just like in the 20th century, but in a much shorter time. Thanks to artificial intelligence, electric vehicles, and even cryptocurrencies, if every car in the U.S. went electric, we'd need 20 to 50% more electricity nationwide. And we can't just do it with renewable energy alone. Right now, renewables make up only 13% of U.S. energy consumption. Solar panels don't work at night, and wind turbines only spin about 35% of the time. Meanwhile, nuclear plants, well, they're cranking out energy more than 90% of the time. Nuclear energy is a low-emission, high-capacity solution to our energy challenges, but it's often misunderstood and underestimated. Thankfully, our friends at Uranium Royalty Corporation are working to change that. They're the first and only publicly traded, pure-play royalty business in the uranium sector. What does that mean? Well, it means they don't own or operate uranium mines. Instead, they invest in them and secure a percentage of what's produced. Their portfolio spans 19 royalties across key uranium-producing regions, including Cigar Lake, one of the largest and highest-grade uranium deposits on Earth. With the growing need for clean, reliable energy, Uranium Royalty Corporation is ready for the coming surge in demand. If you want to be part of the solution and maybe make a smart investment, speaking of things that have existed for billions of years, let's talk about bacteria. Just like today, it was causing some big issues back then too. Let's travel back to Earth about 2.5 billion years ago to see what I mean. Like the calm before the mass extinction event, everything looks great on Earth. Our young sun is a bit dimmer, even a little cooler. But temperatures on Earth are balmy, around 21 OC, 70 of. There is plenty of liquid water on Earth, but no ice. The carbon dioxide and methane in the atmosphere are driving a greenhouse effect. The only life that's around is in the water, and again, I'm not talking about fish. It's all single-celled organisms like bacteria, which were living in very different circumstances, like the zero-oxygen environment you're standing in right now. But this water isn't only filled with boring bacteria. It's now filled with cyanobacteria. This bacteria evolved with a special trait, the ability to use water as fuel to photosynthesize. And with this trait, it was able to produce oxygen. The cyanobacteria began to change the chemistry of Earth's atmosphere. As bigger and bigger colonies of cyanobacteria photosynthesized, they produced more and more oxygen. Now, this didn't result in much at the start, as much of the oxygen being produced would react with minerals and then get removed from the environment. But fast forward a few 100 million years, and things start to change drastically. Now so much oxygen is being produced that it can't be removed fast enough. It oxygenates the water. It escapes into the air. It reacts with methane and displaces it from the atmosphere. Earth's atmosphere is filling up with oxygen and becoming breathable. But don't take off that mask just yet. The oxygen level is still only 10–40% of what it is today, maybe even lower. But this level is obviously much higher than the near zero level Earth had before. So how do the other bacteria react to this new level of oxygen? You can't see it happening because they're microscopic, but they're dying off in huge numbers. This is the Great Oxidation Event, also known as the biggest extinction event in Earth's history. The oxygen being created turned out to be pure poison for other bacteria, killing off 99% of all life on Earth. And this isn't the only catastrophic event happening. This massive amount of oxygen in the atmosphere is about to have a big impact on something else. Now the cyanobacteria is creating oxygen, but it's also wiping out two greenhouse gases, carbon dioxide and methane. These two gases played a key role in the evolution of Earth up until now. They helped trap the sun's energy, keeping the planet warm. With both of these elements being removed and oxygen taking their place, it's starting to get very, very cold. Over hundreds of millions of years, you'd see massive changes in the landscape. The oceans are freezing. Sheets of ice are covering Earth. Brown and rocky land is now turning snow-white. One of the earliest ice ages has begun. This is the start of the Huronian glaciation. It'll last about 200 million years. Throughout this time, you'll see Earth go through 3 glaciations. No part of the planet is spared. The continents, the poles, even at sea level. It's all ice, all the time. Now, all life on Earth has already taken a severe beating, and these chilly conditions aren't doing much to help. Neither the oxygen nor the deep freeze are doing any good for the survival of our older microbes. But somehow, a small sliver of life, just around 1% of the living, persists over these 200 million years. Sorry, you still can't see them. They're still microscopic and living in rare parts of the Earth. They're just hanging on, waiting for the ice to thaw. Oh. All these processes are working to warm up the Earth. The warming sun, greenhouse gases from volcanoes, and in this particular spot, Earth's very own nuclear reactor. As temperatures rise, water is becoming more prevalent than ice, and the land. Massive Nuna is shrinking. One more important thing is happening right now. You can't see a lot of it without a microscope, but the 1% of microorganisms that made it through the Ice Age are wiggling their toes, metaphorically speaking, and starting to thrive. New life evolved during the oxygen-rich Ice Age. Microorganisms evolved that took in oxygen to burn food and released carbon dioxide in the process. The carbon dioxide released was then used by the cyanobacteria to produce more oxygen. This was happening at a microscopic level. Today, it happens with all kinds of different creatures. Now humans and animals breathe in oxygen and exhale carbon dioxide. Plants take in carbon dioxide, photosynthesize, and release oxygen. So, this cyanobacteria was one of the original building blocks for all life today. But the oxygen didn't just power up microbes. During the long ice age, it began to form a protective layer in the upper atmosphere of the Earth, the ozone layer. This protected new life from ultraviolet radiation. Practically speaking, it expanded the real estate of Earth. Microbial life could now live on thin films of water protected from radiation and use the sun's energy to photosynthesize. You know what? I just remembered I packed a special microscope in the time machine. I know, sorry, we could have used it earlier. But you can use it to take a better look now at how cellular life is evolving. At this point in history, cells are changing to be more complex, with a distinct nucleus. This will allow the first plants to borrow traits from the cyanobacteria, which allows them to photosynthesize. So we can thank these microorganisms for the creation of all the plant life we have today. Without photosynthesis, they just wouldn't exist. Other creatures also began to form during this time too. Scientists have unearthed fossils of multicellular creatures. These are sea creatures with soft, gelatinous bodies. They come in many different sizes, some as long as 17 centimeters long. At the time, they probably burrowed into the mud of rivers. These particular creatures survived while oxygen concentrations were high, but later disappeared, leaving no direct descendants. Rest in peace, little guys. Their complex multicellular life is the basic blueprint for all multicellular life today. Plants, humans, animals, and fungi. Even the algae from this time didn't disappear completely.